In this video, we will be learning about empty sets. So, what is an empty set? An empty set is going to be a set that contains no elements inside of it. Essentially, the elements are empty or the set is just empty. So we use two notations to describe this special set. We have a 0 with a line across it, which is called a null notation. And then we have the closed bracket notation, which is just two brackets with no elements inside of it. Essentially, these two things mean the same thing. It's just up to whichever one you want to choose to use. So for this first lecture problem, it says represent the set of prime numbers less than 1 symbolically. So first you need to recall, what is a prime number? So a prime number is going to be a whole number greater than 1 that cannot be exactly divided by any whole number other than itself and 1. So for example, we know that 3 is a prime number because we can divide 3 by 1 and 3 and we'll still get a whole number back out of that division. But we know that 4 is not going to be a prime number because we can divide 4 by 1 and 4, but we can also divide it by 2. So we know that 4 is not a prime number. So for this set, it wants us to represent the set of prime numbers less than 1, but prime numbers are going to be numbers that are greater than 1. So we're going in the opposite direction of what a prime number is. So we know that there's going to be no elements in this set because we're going the opposite direction of what a prime number is. Instead of being greater than 1, we're trying to figure out what's less than 1 that's a prime number. So it doesn't fit the criteria of what a prime number is. So we can represent this set with the null notation, or we can use the closed bracket notation. Either one works, and that's going to be your answer. So for the second lecture problem, it says represent the set of even numbers that are also odd symbolically. So we know that even numbers are going to be numbers that we can divide by 2 and not get a remainder. So for example, we can divide 2 by 2, which will give us 1. So we know we have no remainder and 1 is just a whole number. So that means that 2 is going to be an even number. If we divide 4 by 2, we're going to get 2, which gives us another whole number. So we know that 4 is even. Now if we divided 3 by 2, we're going to get 1.5 or just 3/2, which has a remainder. So we know that this number is not even. This means that this number is going to be odd. A number is either even or odd. They cannot be both. So since we know this information, the set here says we want a number that is even and also odd, but they can either be one or the other. They cannot be both. So there's no set that can describe this exact definition here. So we know that this set is going to be empty. So that's going to be your answer. So for this third lecture problem, it says represent the set of all triangles with 4 sides symbolically. We know that triangles are going to be shapes that have 3 sides, but here it wants us to represent the set of all triangles with 4 sides, which doesn't exactly fit in the definition of what a triangle is. So we know that no possible triangle will have 4 sides, it can only have 3. So knowing this information, we can say that this set is going to be empty because there's not going to be any triangles or elements that fit this definition. So we can put the null notation or the closed brackets. I'm going to put the null notation, and that is going to be your answer. Hey everyone, before we get back to the video, I just want to give a reminder to like the video if you enjoyed it, leave a comment down below if you have anything to say about the video, hit the subscribe button to stay up to date with some of the content I post, and to turn on post notifications to be notified when I upload. Thank you.